Okay, let's say we want to set up a quadratic model for the relationship between the speed at which the car is driven and its gas mileage. So we've entered speeds into the L1 list. These are the x values, 30, 50 and 70 kilometers per hour respectively. And we've entered the corresponding recorded gas mileage into the L2 list. So these are the y values, 22, 31 and 19. So for instance, if a car was driven at 30 miles an hour, the gas mileage was recorded at 22 miles per gallon. So to generate a quadratic curve which fits these points, we go to Stat, Calc, and choose number 5, which is quadratic regression. And we'll just run this, although it's been run before, we'll run it again. And we'll see that the equation is that the gas mileage is negative 0.02625 times the speed squared, plus 2.55 times the speed, minus 30.875. And it's easy to paste that into the y equals window. And if you want to see how to do this, I'll clear it and do it now. So I just go to the y equals window, then go to vars. What we want to paste comes from statistics, so we'll go down to 5 and choose statistics. It's an equation, so we'll scroll across the top to EQ, and it's a regression equation, so if we press enter, we're all set. And it's pasted the equation into y1. Now, for a window, we've got to think about this problem relating to speeds and gas mileage. So if x is speed in miles per hour, obviously reasonable speeds might be 0 to 120 miles an hour. By the way, when you're doing this, don't just look at the 3 given data points. Look at all the values given in the question, because you may see that the question will require you to calculate gas mileage for traveling at 130 miles an hour, although that's unlikely. But read the whole question and see what other values occur in the question, and try to ensure that these values will be available within the window you define. So we'll make the x scale 20, and the y minimum, since it's gas mileage, 0 is a good minimum, and maximum, well, 50 is a good maximum for most cars. So now let's graph this. And this is our graph. One thing I might change is that the scale on the y-axis, instead of having 1, it might be useful to have that y-axis scale be 10. And if we check the graph again, we can see now that the scale on the y-axis is 10. So this is 10. This represents a gas mileage of 10. This represents gas mileage of 20 miles per gallon. This represents gas mileage of 30 miles per gallon. So what we're going to do now is calculate the gas mileage for a given speed using the calculator. Now obviously we sub in a given value into the quadratic equation. The calculator will allow us to calculate this quickly. Once we have the graph up, all we need to do is hit trace. So we hit trace, and let's say we want to know the gas mileage when the speed is 45 miles an hour. So having hit trace, we then type 45, and you'll notice x equals 45 appears on the screen right here, and then just hit enter. So we know that when x is 45, the gas mileage is 30.72 approximately. To show one more example of that, say we wanted to know the gas mileage when the speed was 60, we hit trace, type 60, and hit enter. And at 60 miles per hour, the gas mileage is 27.625 miles per gallon. So that's very useful. 2 other things we want to do. One, we'd like to be able to find the maximum point on a curve. And in this case, the maximum point will tell us the optimal speed to drive for best gas mileage and what that best gas mileage is. So let's do this. To find the maximum, go to second trace, which corresponds to calculate for the curve. Choose 4. You will see the cursor appear in the curve and ask you for a left bound. So let's go left of the maximum using the scroll arrows. And we're satisfied that we're just slightly left of the maximum. Hit enter. And this point now gets fixed. You can see the little triangular marking up here showing where you fixed the left bound. Then it'll ask for a right bound, so we scroll across until we're to the right of the maximum. When we're satisfied that we're in a good place to the right of the desired maximum, hit enter. And now we're asked to guess. So let's just move into the middle, where we think the maximum might be, and press enter. So the maximum turns out to be 48.57, that's a speed, and the y value is 31.05, that's a gas mileage. In other words, driving at a speed of 48.57 will give us the optimal gas mileage of 31.05 miles per gallon. And that's how to do that. Let's say we ask a slightly different question. Let's say we want to keep our gas mileage above 25 miles per gallon. So to represent this issue, we're going to go back to y equals and just enter in 25. y2 equals 25. And let's graph this. So now we have a line on a graph, which is the horizontal line y equals 25. So therefore, the region where the gas mileage is 25 is here on the curve. It's this piece of the curve, and to find the corresponding speeds, we'd have to get the intersections and drop down to the x-axis. But we can use the calculator to get the intersections quite easily. We just press second, trace, which gives us calculation for the graph, and choose 5, which is intersect. So let's look at the first curve here, the parabola. We pick a point on the first curve by clicking enter. Now you can see that there's a cross on the first curve, which marks where we chose our first point. And also notice that the cursor has now moved from the parabola to the line, which is the second curve. And we need to move along the second curve in such a way that the 2 points we're going to choose, we've already chosen the first, the 2 points we choose will trap the intersection between them. So when we press enter, we've defined a point on the second curve. And now we need to move to where we think the intersection is to produce a guess. So we're going to guess right here, and press enter. And the calculator tells us that the intersection is 63.8 roughly, comma 25. In other words, a speed of 63.757351 will yield a gas mileage of 25 miles per gallon. If we go beyond that speed, our gas mileage will drop. But to the right of that speed, for a certain interval, the gas mileage will be above 25. We now need to find the second intersection, and to do that, we're going to go to second trace again, which gives us calculate menu for graphs, choose 5. We're going to scroll across so that on the parabola we are to the left of the first intersection with the line. So I'm now going to choose a point on the parabola, which is our first curve. Choose a point. The calculator will ask me to choose a point on the line, which must be to the right of the desired intersection. I press enter again. And now the calculator asks me to guess. So I move to roughly where the intersection is and press enter. And the calculator produces an answer for the intersection. So at this point, x is 33.4 roughly and y is 25. So these intersections represent the speeds. The x-coordinates of these intersections represent the speeds between which we must drive to achieve a gas mileage more than 25 miles per gallon. And that's it.